Okay, let's start a discussion on uncertainty principle. Uncertainty principle. Okay, uncertainty principle, which was put forward by a scientist called Heisenberg. Okay. So what does it say? It states that there will be uncertainties. There will be uncertainties in position and momentum of very small particles like electrons. This is the actual statement of the principle. There will be uncertainties in position and momentum of very small particles like electrons. This can also be stated as the position and momentum of very small particles like electrons cannot be determined simultaneously and accurately. So you have to listen to these two words. One is simultaneous and the other is accurate. What does it say is the position and momentum of very small particles cannot be simultaneously and accurately determined. When you say that something cannot be accurately determined, it only means that there is inaccuracy in the measurement, there is error in the measurement. So measurement cannot be accurate means there will be error in the measurement. It is this error that we mean by the term uncertainty. So we are getting a new meaning to uncertainty. Uncertainty means error. Error in the measurement. Uncertainty means error in the measurement, nothing else. Error in the measurement, nothing else. So here we are going to measure position and momentum of very small particles like electrons. Either we try to measure the position or we try to measure the momentum. The principle says that there will be error. So there are two errors or there are two uncertainties. Okay, there will be two uncertainties. One is uncertainty in position. Uncertainty in position. And the other is uncertainty in momentum. So these are the two uncertainties that are there. Uncertainty in position and uncertainty. Uncertainty in position means the error that is there in the measurement of position, and the uncertainty in momentum means the error that may be there in the measurement of momentum. Now, the uncertainty in position is going to be represented by delta x, and the uncertainty in momentum is going to be represented by delta p. And the calculations show that the combined uncertainty or the combined error is found to be, that is delta x into delta p delta x into delta p is calculated to be greater than or equal to h by 4 pi. Okay, the combined error is calculated to be greater than or equal to h by 4 pi. And let us examine the terms h, 4 and pi. What's h? H is Planck's constant. It's a non-zero number. H is a non-zero number. 4 is also a non-zero number, as you know. Pi is also a non-zero number. So what I am telling is, if you write this relation as delta x into delta p is equal to h by 4 pi, you know that h4 and pi are non-zero numbers, therefore h by 4 pi is not equal to 0. Since h4 and pi are non-zero numbers, we can conclude that delta x and delta p, that is uncertainty, the combined uncertainty or the combined error is equal to h by 4 pi, which is not equal to 0. That is, what you can write is delta x into delta p is not equal to 0. Yes or no? Delta x into delta p is not equal to 0. That is, the combined error is not equal to 0. What I am telling is, combined error is not equal to 0. The combined error is not equal to 0. Means error is not equal to 0 means there is error. Since delta x into delta p is not equal to 0, mathematically we can say delta x is not equal to 0. Okay? And delta p is not equal to 0. Yes or no? That is, if the combined error is not equal to 0, neither of the errors is 0. Neither of the errors is 0. You know what's delta x? Delta x is the error in the measurement of position. That's not equal to 0. The error in the measurement of position is not equal to 0. And what's delta p? Error in the measurement of momentum. That also is not equal to 0. That is, there will be error. There will be error. So what does uncertainty principle say is, there will be error in the measurement of both position and momentum. That means you cannot avoid error. There will be error in the measurement of position and momentum means you cannot avoid error. You cannot measure the position or momentum of very small particles like electrons without error. There will be error. Okay, there will be error means what? The measurement will not be perfect. That is, perfection doesn't belong to man. Perfection doesn't belong to man. We cannot measure it perfectly. Why? Because the combined error is found to be not equal to 0. Okay, let us view it in another way, that is, if delta x is equal to 0, then what should happen? If delta x is equal to 0 or if delta p is equal to 0, what should happen? If either of the errors is equal to 0, then what should happen? You know that the combined error is not equal to 0. If either of the errors is 0, then that means that the other should be infinite. Okay, since delta x and delta p is not equal to 0, it shows that if delta x is equal to 0 or delta p is equal to 0, it means that the other, if delta x is equal to 0, then delta p should be infinity, or if delta p is equal to 0, then what? Delta x should be infinity. That's untenable. Okay, therefore, we can conclude that since delta x and delta p is not equal to 0, delta x is not equal to 0 and delta p is not equal to 0, that is neither of the errors is 0, there will be error in the measurement of position or momentum of electrons. Okay, however sophisticated measuring devices we may use, there will be error in the measurement. That means we cannot measure perfectly. That is, perfection doesn't belong to man. Then I may ask a question, Then to whom the perfection belongs? To whom the perfection belongs? To whom the perfection belongs? The answer is quite clear. It's not to human beings. Then to whom? It's to nature. Okay, the perfection belongs to nature. It doesn't belong to man. That's the absolute meaning of the uncertainty principle. Okay? Thank you.